So in this chapter we've learned how to factor the unfactorable, basically is what I say we've been doing so far. And what I mean by that is, like, if you can't factor something, we used to write prime, but now we have ways to actually do it. So you've learned completing the square, completing the square, and you've learned the quadratic formula. Today you're learning a new way to solve those things that we always thought were prime. And this is getting equations in quadratic form. So a form that is very comfortable for us to factor. You're going to get everything into the form x squared minus or plus x plus 3 equals 0. And then you'll be able to factor it. Let me show you the first example and maybe you'll get an idea of where I'm going with this. So this is the first thing that you're going to solve for. We have x minus 7 quantity squared minus 13 times x minus 7 plus 36 is equal to 0. And so you're looking at this probably and going, how am I supposed to factor this mess? Like, what is this, Miss Whitaker? Trust me, I thought the same thing when I first saw it. But there's a trick to this. Now I see that I have this and this, and they're kind of in the way. They're making things really difficult. So what we do is we use the letter z, and we're going to let z equal x minus 7. So every time you see an x minus 7, you're going to write z instead. So this first thing, x minus 7 squared, guess what? I'm going to write z squared, because I'm annoyed with you, x minus 7. I see another one, so instead of writing minus 13x minus 7, I'm going to write minus 13 z. I have plus 36, and that equals 0. Can I factor that? Absolutely yes, which is what we're going to do. So I know I'm going to have a z, I know I'm going to have a z, I know it all equals 0. I'm trying to think what multiplies to give me 36 and adds to give me negative 13. I'll give you 5 seconds to think about it. 4, 3, 2, 1. Hopefully you came up with minus 9 minus 4. So now we know that z is equal to 4 and 9, which is awesome. You're probably like, yay, we did it. However, think about what our original variable was, x. I know what z is, but do I know what x is in the original variable or the original equation? No, not yet. So we have to use that original z is equal to that we came up with. So we know that z is 4. So I'm going to plug 4 in here. 4 is equal to x minus 7. And then if I add 7 to both sides, I know that x is equal to 11. I'm going to do the same thing with 9. 9 is equal to x minus 7. If I add 7 to both sides, I know that x is equal to 16. So the answer is not z is equal to, let's see if I can move, oh, that's not what I want to do. Oh, I guess that kind of works. Alright, so the answer is not quite this, the answer is actually 11 and 16. So figuring out what z is helpful, but you always have to go one step further to make sure you're figuring out what the original variable actually is. Let's try the next one. Alright, so there's a small typo. That should be x to the 4th minus 9x squared plus 8 equals 0. So there's actually 2 ways to solve this, and I'm going to, I guess, show you both ways since we have time. Maybe. Yes, I'm going to show you both ways. So this one you might be able to actually look at and factor. And so you're thinking, okay, what's going to multiply? I see I have x to the 4th, so I know x squared. Oops. And x squared will give me x to the 4th. And then you're thinking, what multiplies to give me 8 but adds to give me negative 9? Should be negative 1 and negative 8. And so those are your two things. Can you factor either of them anymore? I'll give you 5 seconds to decide. Hopefully you're thinking yes. 4, 3, 2, 1. Yes, this is the difference of two squares. And then I still have x squared minus 8 is equal to 0. In order to figure out what my x's are, I'm going to set all of these equal to 0. Oh, whoops, oh, whoops. So x minus 1 equals 0. X plus 1 equals 0. X squared minus 8 is equal to 0. So when you add 1 to both sides, you realize that x is equal to 1. When you subtract 1 from both sides, you realize that x is equal to negative 1. This one you got to do a couple steps. We're going to add 8. So you get that x squared is equal to 8. Then you're going to square root both sides. And you realize that x is equal to, I'm going to go ahead and simplify, 2 square roots of 2. Wrong. Hopefully you realize that you need to plus or minus it. PS graded your tests. We forgot that a couple of times. Plus or minus 2 square roots of 2. Cha-ching! So this 4 is going to be your big hint that you're going to have 4 answers. 1. Oh, what am I thinking? Sorry. 1 answer. There's your second. And then here are your third and your fourth. The positive 2 square roots of 2 and the negatives 2 square roots of 2. So x is equal to negative 1, 1, and then plus or minus 2 square roots of 2. That is one way to solve this problem. Let me show you the other way to solve this problem. So when we solve it this way, we are going to let z equal x squared. So anytime you see an x squared, we're going to write z. This has x to the 4th though, which means we have 2 of those z's, because that's x squared, this one's x to the 4th, so your x to the 4th actually becomes z squared, minus your x squared just becomes z plus 8 equals 0. From here you factor z, what am I thinking, minus 1, z minus 8, and so then you realize z is equal to 1 and 8, but then you got to plug them back in up here. And so I'm taking these and I'm plugging them in, for here. So you have 1 is equal to x squared, and you have 8 is equal to x squared. Got to square root both sides. You get plus or minus 1. Got to square root both sides, and you get plus or minus 2 square roots of 2. Boom. I don't know which way is easier to you, but when it's to the 4th, you can either factor, or you can just substitute in and make it something that's very easy to factor, like that example right there. Let's move on to the next. Alright, so for this example, I'm looking and I'm like, oh, I really don't like this radical right here. Boom. How can I get rid of it? Dun, da, da, da. We're going to use our z trick. We're going to let z equal the thing we don't like, which is our square root of 2x. So I know I'm going to replace my square root of 2x with z, but I want to think for a second, where would my z squared go? Because I know something has to be squared. Well, think about it. If I square z, that means I have to square this, which means those cancel and you're left with 2x. So anytime you see 2x, you're going to put the z squared, and anytime you see the square root of 2x, you're just going to put z. So boom, I see my first 2x. That means instead of writing 2x, I'm going to write z squared. I have plus 2. I see that square root of 2x. Yuck, I don't like it. There's where my z is. And I have minus 15 equals 0. Now I have something that's super easy to factor. Z and z. I'll give you 5 seconds to think about this one. 4, 3, 2, 1. Did you come up with plus 5 minus 3? Fingers crossed. So then we know that z is equal to -5 and 3. And this is the tricky part. You're probably like, yay, I'm done. Just kidding, you're not. Don't forget, you have to take those and plug them both back in here. So I'm going to take -5 is equal to the square root of 2x, and 3 is equal to the square root of 2x. Now this one's kind of tricky and evil, and I feel bad that it's in here, but I'm sure that it's in your homework and probably on your test, so I'm giving you a heads up. I plugged -5 back in here. It says -5 is equal to the square root of something. Think for 2 seconds. Is there anything I can plug in for x that will get me a negative number? Can I square root anything and end up with a negative? Absolutely not. So the answer to this particular equation is no solution. That one's tricky because I would have just squared both sides, but you can't because you can't square a root and get a negative number out. So that one ends up being no solution. This one, though, this is a positive number, so yes, I am going to square both sides. And you end up with 9 is equal to 2x. You divide both sides by 2. And so the only answer to this particular problem is 9/2. Here's my last example for you. Solving 6/u minus 17 all over the square root of u is equal to -5. Again, which one of these things looks the yuckiest? That's what you're going to let z equal. Well, this whole thing looks gross, and I would really like to get rid of it. So what I'm going to do is have z equal 1 all over the square root of u. I want to get rid of it, which means z squared is going to equal 1 all over u. So now I'm going to rewrite my original equation to make things better. I see I have 6/u, which now means that I have 6z squareds. And I see that I have minus 17 all over the square root of u, which means I have minus 17 z's equals -5. This is something I can almost factor. I just got to move him over here by adding 5 to both sides. So then I have 6z squared minus 17z plus 5, and that's equal to 0. Now we must factor. This one's a little bit trickier. I will give you 10 seconds to see if you can figure it out. 10. 5, 3, 2, and 1. Did you come up with 2z minus 5 and 3z minus 1? Hopefully that is a yes. Cha-ching! So now I'm going to set both of those equal to 0 to figure out what in the world z is. So 2z minus 5 equals 0, and 3z minus 1 equals 0. I add 5 to both sides and get 2z is equal to 5. Divide by 2, so I know z is equal to 5/2. And then over here, 3z is equal to 1, so z is equal to 1/3. Halfway done. I figured out my z's, but remember the original problem had u's, so I must figure out my u's. If you remember, my original problem said that z was equal to 1 all over the square root of u, so that means I'm plugging this in here, and I got to plug that in there. So I have one equation, 5/2 is equal to 1 all over the square root of u. And I have 1/3 is equal to 1 all over the square root of u. I'm going to multiply both sides by the square root of u. And I end up with 5 square roots of u all over 2 is equal to 1. I'm then going to multiply both sides by 2. So 5 square roots of u is equal to 2. Divide, divide, and the square root of u is equal to 2/5. So there's one of the answers. And we're going to do the same thing up here. Times the square root of u, times the square root of u. So we have the square root of u all over 3 is equal to 1. I'm going to multiply both sides by 3. And when I do that, I end up with the square root of u is equal to 3. The only issue with both of these answers is that u is still not by itself. So I need to square this, and I'm going to square this. So really, I end up with, let's write this in purple. This one gives me u is equal to 4 over 25. And this one gives me 9. So the answer to this big jumbled mess is u is equal to 4 over 25 and 9. This is your homework. I gave you the odds so you could kind of check as you worked. These are tricky. We've not done anything like this before. Remember, just use the variable z and let it equal whatever is yucky, whatever you don't like. So sometimes it's going to equal something that looks like this. Sometimes z is going to equal something that looks like this. Sometimes z might equal just a simple x squared. And then sometimes z might equal a fraction. So you've got a lot of options, but just keep in mind that the variable z can equal whatever you want, whatever's yucky within the problem. I wish you luck.